Hello, I'm Morgan By, and in this video I'd like to take just a few minutes to show you around the latest addition to the EPR toolbox, cwViewer. So the EPR toolbox is just a few useful scripts and tools that I've put together whilst I've been spending my time at the University of East Anglia, and I believe that it's good practice that if I'm using these things on a regular basis, then I believe that they're probably useful to other people out there as well. So I make these freely available to people. So, cwViewer then. My main aim with cwViewer is that once you've got your files off the spectrometer, it is actually quite hard to manipulate them in any way. It's intuitive and quite quick and easy to do so. So this toolbox goes a little way to making life a little bit easier for yourself. So what I've done here is I've literally downloaded, well, I haven't downloaded because I've developed. I've downloaded the latest toolbox and I've extracted them, and then I've added them to my active folder by right clicking on it and adding to path and then selected folders. From then you can just type cwViewer into your command window and windows like this should appear. So on the splash screen, or the home screen, you get a shameless piece of advertising, but I don't think that's too bad considering the time that's gone into this one necessarily. So if I just change my current folder to my test folder so I can actually show you what this thing can do. So I think most people, when they load cwViewer for the first time, will just start to want to try and get some files in. So at the moment I'm mostly using Brooker files, because Brooker instruments are what we have in the lab, but I am working on adding jail support and FSC2 support. So you can just click on Load Brooker, and this will bring up a nice user interface for selecting Brooker files. It will also do the slightly older Brooker spec files, but I've had very limited ability to test these as I don't really use that standard too much. So you can simply navigate to a folder of your choice. So here I've got just a folder of standards, and here we've just got some spin labels at varying concentrations. If I click one at random and open, you'll see that straight away the file has been loaded and plotted quite nicely. And so we've got intensity on our y-axis against magnetic field on our x-axis. You'll see also that our file details window up here has been updated, and it tells us that we've loaded one file, and it tells us the title of the file as well as the frequency at which this file was recorded. So this was taken at X band, and it was used 16 scans with a microwave power of 0.6 milliwatts. So this is quite a nice smooth spectra already, so I might just load one that I know is going to be a little more easier to play with and show you some features. So if I deliberately now pick a spectrum that is a little weaker, so we're now going to 10 micromolar rather than 10 millimolar, and you'll see that there's a fair bit, well, not too much, but there is some noise along our axis. So from here, we can now try some data manipulation with our little data manipulation box here. So the first thing that I usually like to do is click this auto zero box. Now what auto zero does is it's a very rudimentary baseline correction. So it takes the first 10% of your data points and the last 10% of your data points, averages it, and just says, right, that's clearly my baseline, and sets that to 0, and then moves all of your data points accordingly. As I say, it is very rudimentary, but as long as you've got some baseline and it's relatively smooth to begin with, then it doesn't cause you a problem. The other one that I always like to select is normalize. So what normalize does, if you look at the y-axis again, is it takes your values from whatever axis they're on, and it normalizes between 1 and -1 by taking the highest and lowest point of your data set. Excuse me. So I've also included a few other interesting little tools which I think people will be finding useful. So first of all, we've got a digital smoothing function here. So what this does is create a running average. So it takes the data point and 2 data points either side of it. So it takes 5 data points in total as a standard default value, takes the average of those 5 data points, and then plots the point of the average. So by just clicking this on and off, you should see that there's a nice smoothing effect happening. And so you can smooth your data quite nicely. Now, you need to be a little careful with averaging, because your peak intensity will drop slightly as your peaks are averaged away, so your intensity will drop slightly, and your peaks will broaden slightly here from where the averaging effect occurs, because you won't get the sharpness in your turns. So you have to be a little careful with that. And if I turn this number up to something a little more stupid, I don't know, say 100 even, you'll see that instantly all clarity in your spectrum has disappeared. So you've got to use that one with a little care. The second smoothing function that I include by default is a fast Fourier transformation. So what we do is we Fourier transform in one direction into the frequency, into the frequency domain. I can't remember off the top of my head. And then we do the inverse Fourier transformation back again. And the idea being that should filter out quite a bit of the noise. So if I just click this one on and off, you can see that the effect is much less, but there is some smoothing going on. Again, you have to be a little careful with the smoothing function, because if you're not careful, you will smooth away the actual data that you're trying to look at. So if I start to turn this number up to something really big, then you'll start to see that your smoothing does get a lot better, but you also get a slight, what looks like a digitization from where your data steps a bit. And if you turn this number to something really stupid, you'll find that you actually smooth out the data set that you're actually looking for. So you have to be a little careful with that. So that's the basic features. A little more interestingly though, say I didn't want to just look at one of these files at a time. Let's say that I wanted to look at the entire folder of standards at the same time. So to do that, I can just click on File and Load Brooker Folder. This then again brings me up a nice little graphical user interface, and then I can simply click on the Standard button, and then that's selected that folder, and I can click OK. And what we've done now is we've loaded everything that was in that folder into memory. And if I just click through it, you can see that they're clearly all different. So likewise, because I've still got the normalization and auto zero, these don't look all that different really. But if I turn the auto zero and normalization off, then you'll see that your y-axis varies a bit more. So that's very nice. Now, I in my lab have done a fair bit of power saturation curves, and basically what this is when you take your x-axis and your y-axis is the same, but then you have a third axis or a z dimension, which is microwave power. So for this, if I just load one up for you, what we've got here is essentially an awful lot of graphs or spectra that have been now overlaid on top of each other. Now that's partially because I've got this stacked option in the viewing options highlighted here. Now again, we can use our data manipulation functions, so we can auto zero them so that they now all line on top of each other rather than having a couple of strays like this one here in blue. And if you like, you can normalize them as well, but again, you probably don't want to do that for this situation, but it's a nice feature to have if you want it. So once again, I might turn it off for now, but whilst it's very nice to have all of these, when you've got large data sets like this one clearly is, it isn't always the best way to have everything stacked on top of each other like this. So for that reason, I've included a few other options. So the first one I'll show you is this. It's a single slider, so when you click it, you automatically have just one spectrum that is then plotted, but this little slider on the side here has now appeared, and from this slider you can then just click through and you can see every single one of your spectra individually, which I think is a very nice feature to have. So if you want to see a particular spectrum, unfortunately at the moment every time you click through on one of these the microwave power should change, and it's not, so I will change that once this video is concluded. But maybe you don't want single, you want more of a stacked view, but you don't want them on top of each other necessarily. So to do that I've got a staggered option. So automatically I've clicked staggered, and what it's done is plotted everything on top of each other, which is fine, but that's not very helpful to us. What would be more helpful to us, say, is if we staggered them slightly. So by ticking this y-axis, what I've done is just staggered the plotting. Now there is a little bit of overlap here, so I might increase this a little bit, maybe even a little bit more. So if I increase that to 1, we should be able to see a little more spacing between each of the spectrum, and in fact I might increase that again. So there we have it. We've had now a nice spreading so you can see the data points, and if you now select the y-axis, what we've now done is create an offset, so we've now got a diagonal function, so you can better see all of your spectra, which I think is very nice. Now these graphs at the front have sort of given precedent, and these ones at the top are kind of starting to get cut off, and that's because the axes are automatically set to be quite tight to what you've got on the screen. Now you can obviously change this by clicking on axes manual, and then you can change these values to better suit your needs. So I don't know, if you don't want this to be 51, you want a little more space at the top, you can just turn that to 55, and you might want a little more space at the bottom, so you can just change this to -5. Then maybe, I don't know, you might want this from 340, well maybe not 340, maybe 344 then, to 353, and then there you are, you've got a much nicer graph to present. So once you've got a nice picture like this and you're happy with it, you've then got a fair few number of options that you like. So straight away you can go File, Export, and you can create a nice image. So if I click that, we now gives you a nice graphical user interface to save the picture as something you want. By default I've got it set to encapsulate PostScript fonts because I'm a LaTeX user and that's what I like to use, but for other people there are portable network graphics, bitmaps and figures, so nice and easy for you. So there are a couple of other options, so I don't know if I've been playing around with this. Notice because I haven't put the axis back to automatic, it's still plotting on the same range, so that's a bit nicer. So say I've now zeroed and normalized it, I can now export this as a data set. So once I'm happy with it, this allows me to save my data set either as a Brooker file, which might be useful to you if you want to go back to EPR on a spectrometer, or by default I've got it set up so that it exports things as a comma separated value. So these are spreadsheet friendly, so if you want to export to Excel or OpenOffice or Origin to do some actual plotting of graphs, because MATLAB isn't that great for plotting of graphs unless you're really happy with the command line interface, then you might want to export it as a comma separated value, and then you'll be able to import it. So as I've just exported that, and what's the quickest way to show you this? Then if I go into this and open with just my text editor, you'll see that what you get is just a very simple file really, with your x-axis and your y-axis, and then just a page of numbers. So that's quite nice and easy. What else have we got? So a nice feature that I also have included in this is that, say that you've now got your 12 12 files loaded, and you've imported them in a special order, and that's how you like them. So what you can do now is file and save your workspace. So what this now does is allows us to save our cwViewer as a MATLAB structure and click save, and you'll see that in the folder it's come up as a .mat file. Now when we actually close cwViewer, you'll get a nice prompt saying, are you sure you want to quit, just in case you hit that by accident, and you can close it. Now if we reload cwViewer, and the windows have gone slightly askew, so I'll have to look at that again when this video is over. So now when I go File, Open, I should be able to now select the cwViewer from last time and open it. So I'm not quite sure what's gone on there. There we go. And you'll see that all 13 files have now been loaded back into the workspace with the correct values. And hopefully it should have also saved your preferences for your viewing options. So that's a nice little feature, especially if you've been working on large data sets and it's taken you a while to load all of them in, because sometimes you don't necessarily want to load an entire folder at once, but you don't necessarily want to load only a single file. So there you have it. That is basically the functionality of cwViewer at the moment.